In the range of firefighting tactics available to an officer in charge of an incident, one of the main methods for controlling a fire in a building is ventilation. It should be considered as part of the ongoing dynamic risk assessment at the scene. Ventilation is the planned and systematic removal of heated air, smoke and other airborne contaminants from a structure and their replacement with a supply of fresher air. It follows from this definition that the proper use of ventilation can improve the environment in which the fire is being tackled. In firefighting operations, the prevailing wind will dictate the way in which ventilation is best used. It is often a controlling factor to many events worldwide. But used skillfully, it can provide significant benefits. Air and gases inside a building will always try to find a stable state, but the weather outside the building will influence how to vent it. Wind flow around buildings can be complex, but at its simplest, the windward side or approach side is called the upwind side, and the leeward or departure side is the downwind side. This will create a positive pressure on its approach at the upwind side and a negative pressure on the downwind side. This pressure difference will assist the process of ventilation if the outlet vent is downwind and the inlet vent is upwind. Any venting should always be done in a controlled manner. It is important to wait for a clear instruction before making any opening. To introduce a good oxygen supply to a flammable atmosphere can have dramatic consequences. So at all times, it must be under the control of the officer in charge who has the responsibility for coordinating it with other fireground actions. The proper use and timing of ventilation is critical.
We're actually in an incident and nobody told us that they'd opened windows at the back of the premises, and we were lucky to get out alive.
Effective fireground communications are essential in order to ensure the safety of crews and other people in the building. Before authorizing ventilation, an OIC must decide the objective. There are two types of tactical ventilation: defensive and offensive. Defensive ventilation is used away from the seat of the fire, possibly outside the fire compartment, in order to dispel hot gases and smoke. This will improve access and visibility, making escape routes safer and also prevent the spread of smoke to other parts of the building. Eyes should always be properly protected, as glass can shatter and cause cuts to you on the ladder or to people down below. Breathing apparatus should always be worn. Offensive ventilation is used close to the fire plume in order to have a direct effect on the fire itself. And in so doing, it can limit fire spread and make conditions safer and more tenable. It must always be remembered that when tactical ventilation is used before extinction, it may have a dangerous effect on fire spread if used unwisely. The first stage in venting a room is to make an outlet vent. On the route to the vent, hot gases will always present a risk of fire spread, so this distance should be kept as short as possible. Hot gases and smoke are buoyant and will rise. This means that the dangerous byproducts of combustion will be best controlled by venting as close to the fire and as high up as possible. When vertical ventilation, making a hole in a roof, is chosen by the officer in charge, careful consideration should be given to the safety of firefighters, both above and below, due to the possibility of structural failure. Timbers may be fire weakened, and at 600 degrees centigrade, even steel has only 1/3 of its normal strength. Firefighters should always position themselves at a lower level than the opening they are making, to minimize any risk of injury.
You must position yourself properly on the ladder in case a jet of flame shoots out, which could either burn you or knock you off the ladder.
There is also the danger of fire spread outside the opening. Any venting activity should be covered by a charged hose line in order to start defensive measures before problems develop. The second stage of any venting tactic is to create a lower opening through which air will enter to compensate for the loss of gases higher up. It is important that this opening is made almost immediately after the outlet vent to stop air from being drawn into the fire through the wrong vent. When vertical ventilation is too difficult or too dangerous, horizontal ventilation will be the only alternative. Horizontal ventilation is the term for making use of doorways or windows in the fire compartment. And here also, it will always be most effective to have the outlet vent as high as possible and the inlet vent as low as possible. The internal design or layout of a building can significantly affect fire growth and smoke logging. This may mean that the passage of smoke and gases is unpredictable. Before the fire floor is ventilated, it is essential to ensure that the resulting air movements will be appropriate for effective, safe ventilation. When using horizontal ventilation, and the only suitable openings are all on the same side of the building, the use of natural ventilation may be ineffective. This is because the pressure of the prevailing wind will act equally on the inlet and outlet vents. This is one example of when forced ventilation can be used to create air movement. Positive pressure ventilation, PPV, is the term used when the pressure inside a building is increased by mechanical means. The inherent danger of providing a good supply of oxygen to the fire environment is a risk here also, but possibly on a more dramatic scale. The position of any forced draft should always be determined by the direction of the prevailing wind. Even PPV can't fight a strong wind. PPV enables firefighters to have control over the inlet route for the air, but not necessarily the outlet route, so it may be appropriate for the officer in charge to withdraw teams from the building before using PPV. If things are going to go wrong, they can go wrong more quickly when using forced ventilation.
People tend to forget. If things are going wrong, you can always turn the damn thing off.
The building trend in cities is towards high-rise blocks, possibly with underground car parks. Local conditions in atriums and full-height stairwells can also cause problems for firefighters. The first of these is the stack effect, where large vertical spaces inside the building act as a chimney for hot smoke and gases that are ultimately trying to find a means of escape. If there is an inlet at low level and an outlet at very high level, fast air movements can develop between the two, fanning the fire. Another possibility is that with no means of escape, the gases will cool as they rise, gradually forming a static layer of smoke which may build up, spreading around the building. It should also be remembered that in gaining access to the lower floors, firefighters can inadvertently open up an inlet vent, and this may result in the products of combustion moving around the building. The possibility of accidental venting in this way, or even by well-intentioned members of the public, may result in increased fire growth or even a backdraft. Ventilation can be a powerful tactic, but it is only one of many operational tactics open to the OIC. Ventilation can be used to minimize smoke damage, aid escape, reduce contaminants, and therefore property damage. It can also speed up the attack through the creation of a better working environment. It is essential to have good communications and effective teamwork. The implications of any action must be thought through before implementation to ensure the safety of personnel at all times. When using ventilation, observe the following rules. Identify the direction of the prevailing wind and make use of it. Always consider carefully the implications of venting before any action is taken. Make the outlet vent first as high as possible, ensuring it is on the downwind side of the building. Because of the risk of fire spread during offensive venting, ensure that the outlet vent is covered by firefighters with charged hose lines in case of a fireball. Always start inlet venting almost immediately after the outlet vent has been made. At all times, the effects of venting must be closely supervised, and progress inside the building must be reported to the officer in charge. Used incorrectly, it can worsen the incident and even lead to loss of life. But when used carefully, it can have enormous benefits for everyone.